All right, it's 9:30. We've got a little bit of work to do today. Last time we were, what did we do last time? Oh, we finished up the hot end swap. We put in the spider from Creality, so all metal hot end so that we could print hotter. We were trying to print some carbon fiber polycarbonate, which we did do, sort of. We at least got it to extrude and stick down. We're going to continue kind of along that way. I've noticed a couple of things. Let's look at the printer. Oh, I've got to get the printer. Hold on a second. Let's get the camera for the printer working. It might take a second for it to initialize. There it goes. All right, so we're sort of on it. Oh, the dog found something to bark at. So this is not the carbon fiber filament, or well, carbon fiber polycarbonate filament. Here we did. So when we were in class, we got it. I don't see the little piece that we got to print. It was a little short piece that proved that it was at least going to stick down to the bed. That was our initial problem. Is that it wasn't sticking to the bed. We did switch over to glue stick, which seems to have helped, plus hotter temperature after we changed our hot end to something that could print hotter. But the firmware was limiting us to 260 degrees, which was fine. It was extruding. But now our problem here, I did get an entire, let's see if we can get that to focus. We did get an entire vase to print, but it's got some problems. The base is not connected. Well, one little string connected. You can see, well, there's a big crack in it right there. Several cracks over there, if you can see them. I don't know where it's focusing. It wants to focus all over the place. Maybe it's focusing on that. That might be the problem. So it is printing, but it's super weak. Like any little force just causes it to delaminate. And that happens a lot with these higher temperature, like ABS, the polycarbonate type things, where the environment, I'm just printing out in the open. So you can kind of see the printer's just sitting here on a table. It's not enclosed in any way. There's no heated chamber. There's nothing like that. And so it is cooling in a way that does not let the layers adhere to each other very well. I also possibly could have some flow rate issues. Not the same kind of like high flow versus low flow. I just mean it's not tuned correctly. Because I followed that print up with just I thought I'd print one of these silk, prints, and it kind of did a similar thing. It's pretty weak. It didn't crack, but I can pull it apart. I can pull it apart pretty easily. Now, part of that is this is old silk filament, which silk is already kind of the tougher stuff to have layer adhesion. Another part is this is a single wall, and I'm back to the 0.4 millimeter diameter nozzle when we changed out the hot end. I haven't switched it over to our larger nozzle. And so I've got, a couple of issues there that make me think that there could be some flow rate. I guess I could find some calipers and measure our wall thickness and see if we're anywhere near where we're supposed to be. So we're supposed to be at 0.4 millimeters. So let's see what we've got here. Actually, we're over. Well, I don't know. I might be. Actually, it looks like we are a little bit over 0.5 millimeters. So maybe my flow's not too bad, and actually maybe it's over extruding. But I definitely have layer adhesion problems even on this silk, which is not uncommon for a thin wall silk filament. I did not have any of those. This is the that tricolor silky filament, but this is a thicker wall. This is the 8.8 millimeter nozzle. What's sitting on there now is a matte fiber daffodil from Protopasta. It says it can be heat treated. So we haven't done any of that. What that means is that theoretically, and it's not simple to do, but theoretically you can actually heat your printed part, the ones that can be heat treated. There's a couple of them. This is one of them. And it will sort of anneal the part. So it makes it a little bit tougher, a little bit stronger than it was before. The problem is, unless you pack it tightly into some kind of salt or something that holds its shape, it will probably deform on you when you heat treat it. So if dimensional accuracy is important, then the heat treating may not be very useful without that packing process while you're heat treating, which is a little bit hard to do, or at least time consuming to do. So I did not heat treat. It's still stuck to the bed, in fact. I have noticed, remember we put some glue stick on here, and we put that layer near, or whatever it was called, the bed treatment. I don't see the bottle for it right now. And things have been sticking really, really well. So I actually have a little bit of difficulty getting them off of there. So let's see if I can get it off without breaking this one. There we go. So there's our matte fiber, what is it called? Daffodil. So it's a PLA based print with, I don't know what is the included material. It might be sawdust, it might be cardboard, it's something. It actually feels very wood-like, very thin wood-like, but very wood-like. So some of these I know have cardboard particles, some have sawdust type of particles in them. This is probably something like that. It doesn't actually say, at least not on the little bag here. It does say it's unfinished wood color, which I agree. That looks kind of unfinished wood color. I wish it would focus better. I don't know why we're having such a problem wanting it to focus on the right thing. It's trying to focus way back there, and I don't want it to do that. Maybe if we get down closer to where it has to focus on the bed, maybe it'll focus. That's a little better. So you can kind of see it's got a little bit of a grainy texture. There's some darker particles in here, but it's a matte material. So there are shiny, obviously. Well, or, you know, if you get it to print better. Now this is an old sample, probably years old, so I'm not surprised that it kind of didn't come out that well. Although the layers and everything look fine, but the layer adhesion is pretty poor, or actually very poor. And then there's matte, and then there's translucent. I don't know if we've printed many. Well, we printed this. You know, this is a little bit translucent. This is a TPU, though. Remember, if you didn't see that, this is a squishy one. All right, so all of that to say that we're on our way. We've got it to actually extrude and sort of lay down polycarbonate material, but we still have some issues on cracking, warping. One way we can solve that is an enclosure. You can do an enclosure anywhere from a garbage bag over the top of your printer to kind of trap the heat in there, to like something you build with heaters and, you know, a heated chamber. Some printers come already, you know, that's part of what they are. They say they have a heated chamber with them. Not your little Ender 3 printers, though. What we're going to do, not today, but we're going to do another thing today. What we're going to, we basically have a tent type enclosure that I think it's, let me find the price on Amazon. I don't want to tell you the wrong thing. 3D printer enclosure. Oh, it's like $30. So let me get it to show you the right page here. Something like this. I don't know if this is the one I got or one of these. Oh no, February 20. Oh no, that's a different thing. That's the one I must have. So because purchased May 2024, and that would be the right time frame. So $40 or so, and it's a giant bag that has a self-supporting structure and kind of reflective material inside it, and a door, you know, a zipper closed door with a window on it. So they're all kind of the same idea. And you put the whole printer inside of there, and it's not heated. No, like this one is not anyway. I guess you could try and heat it with a space heater or something, but this one's not heated. It basically uses the bed as a heater and just retains the heat that the bed generates. And it eliminates cross flow air, you know, drafts and that sort of thing. So if you put your printer in there, turn up the bed, let it sit for 15-20 minutes to get the chamber heated up, and then start your print, you'll have a little bit better luck on getting the things like the whoa, you're going everywhere there. Getting this layer adhesion a little better. So before I do that though, I do want to, I'm noticing that you can actually see back here where this purge line is super translucent. Some of the, you can see how it's dug in. Now some of this is because there's glue stick on the bed here. So I'm not paying too much attention there, but it's getting really close to the nozzle. Something has changed. So we did change out the hot end, which could have a slightly different nozzle height. Our bed level could have gotten out of whack with me messing with it over time. The Z end stop over here, this little guy, could have gotten a little bit uncalibrated from where it originally was. And so that's something that you might have to do over time, is go back and re-level stuff. We're going to take the other route of, we're going to add automatic leveling so that maybe we can get away without having to do that. Plus, that lets us do another thing too. Two other things. So in order to install this guy, we're going to have to change the firmware on our printer to know that it has a bed sensor on it now. And while we're doing that, while we're changing the firmware, we're going to go ahead and check that, make sure that we have thermal runaway enabled, because some printers don't have that enabled to begin with. And I want that because if you watch the video where we changed out the hot end, I was a little bit suspicious of how the thermistor was attached into the hot end, and I don't want that to come out or anything like that and then give us problems with the thermal runaway situation. So I want to make sure that that's enabled, and it will, remember we were maxed out on the maximum temperature we could ask for, so we could ask for 260 and that was it. But now that we have this new hot end on here, we can go up to 300 without any problems. Then at 300 we start getting new problems of the thermistor readings become nonlinear, and it's a little bit not predictable above 300. So we're going to change those things. We're going to make sure thermal runaway is enabled. We're going to increase our maximum printing temperature. We could mess with speeds and accelerations if we wanted to also, but I want to leave those because we have another plan for that. And then we're going to enable the BL Touch. Well, this is a CR Touch, so the Creality version of what was originally called a BL Touch, which you can still get BL Touch sensors. But basically, this is a Hall effect based sensor that probes your bed surface. So it literally goes in and touches the bed surface and tells you where is it at. There are other types of sensors, some that are non-contact in a variety. You can make your own out of an Allen wrench. There's all kinds of sensors you can create. Some use the nozzle itself, so it knows when the nozzle has touched the bed. This one is going to mount to the side, so we're going to need to get a reposition our camera here a little bit. So we're going to mount it right here, and let's just go ahead and start the mechanical process, and then we'll do the software part. So I have not opened this. Let me see if I can get it to, it's got a little seal on it that I need to cut apart. That's kind of hard. Let's see. All right, there we go. So we get a little bit of, your typical documentation stuff. There's a variety of brackets. We're going to use this one. It's going to go right there. So we're going to use that. But there's other brackets here if you have different setups to mount this on. This is the sensor itself. So there's the little probe. It's going to sit right in there beside the carriage. What else is in here? Oh, there's another bracket. Cable. We have to connect this sensor to, oh wow, we got some extra hot end. Hey, there's actually a hardened steel nozzle in there. So whichever kit I got actually has hardened steel, and I don't know, it might be that that's a 0.6. Let's get it out and see. That'd be super nice if it was. And it's a 0.4, but they did send a hardened steel nozzle, so that's new from the kits I've gotten in the past. Wires to connect it. a couple of zip ties, and some mounting hardware in a couple of bags. All right, so physically mounting it is actually really simple. We take these two screws out, we put this bracket on, and we screw on the sensor. So not a big deal to get it mounted. I might, so no, I'm gonna, looks like I could clear that, I think. So I'm gonna mount the sensor to the bracket first, just to make that a little bit simpler later on. So there are threads in here. You can kind of see they're silver. So we're going to put screws from the bottom. And which screws are we going to use? I think it's these little guys. We're going to have to find it. This one did not come with any tools, but I assume they are knowing that if you bought one of these, then you probably are putting it on a printer, and the printer comes with the right set of tools. So let's just find, I don't know, it looks like, let's just dump it all out. This one? No. This one. All right. So there is a plug where our wires are going to plug, and there's a cutout in our bracket. Actually, that's not the right bracket. There's a cutout in our bracket that needs to match up so that we can actually plug our wires in. Let's see if we can do that and get our other one in there. Oh, I nearly dropped it. Or I actually did drop it, nearly lost it. Is our problem. So some of your printers will come with this built in nowadays. Again, this is like the lowest of low-end Ender 3s that you can get. And so I purposely get the lowest of the low end so that you can kind of see all the different things you could do if your printer doesn't have one of these, or maybe if you do want to go into the firmware. We're about to do that so you can see how that works. And then we're going to keep adding on and changing up this printer until we get something that probably we will spend about the same amount of money as we would if we just bought the nicer printer. Maybe not, because this one was actually really cheap. It was $99 on sale. So maybe this one will be cheaper than if we bought like a Ender version 3 or whatever the current maximum version is. So all I did is I took those two screws out. We've had those out before. While I've got that cover off, I think I will peel it back a little bit and check on the status of our thermistor. It still looks good. So hasn't come loose, and it did print fine for 2 prints, 2 of those vases. Okay, so this is a slightly bit tricky. I've got to get this screw in there. So I went ahead and put the screw in, and then we'll just try and line it all up. This is the new screw. They're slightly, ever so slightly longer than the original ones, because now it has to go through this plate also. See if I can get everything lined up there. It's kind of hard to do while I'm got this camera in the way. Come on. All right, so got it started. Don't tighten it up all the way. That's just a general, that's not anything specific to printers. That's just a general when you're assembling stuff. Get all your screws started, then tighten them down. There's only 2 here, so there's our second one. Let's go back and tighten this one up. Okay. All right, so that's the mechanical mounting of it. Now we need the electrical. So we get a cable, and one end of this cable is small and the other is large. The small end goes to the sensor, and the large end is going to go down in here. Got to get their tie wrap thing here off of it though. I may have to cut it off of there. I can't see the... Alright, there we go. That was easier. Alright, so these plugs will only go one direction, so you do have to make sure you line them up correctly. That should be the right way. There it goes. All right. So now I'm going to have all this wire kind of loose. They do give me 3 zip ties. I have plenty others from even from the original printer. I didn't use all of those. What we'll do with this for now is we're just going to kind of zip tie it to this set of cabling. Actually, right now I'm not going to do anything with it. I'm just going to get it plugged in, and then once we get everything sorted out, we'll attach it to the wires. When you do that, make sure that you attach it in a way to where your printer can actually have its full range of motion. You don't constrain it some way that it can't actually get over to the right side and the very top. So we should be okay, but just make sure that you don't do something that makes it where it can't get to where it needs to go. All right, now we're going to go down here. So let's get a little closer here. These 2 screws, and there's one, we're going to have to move the bed, and it's underneath here. Not remove, just move it. This is also a time I might remind you that this little opening here, there's a fan, cooling fan, to keep your motherboard, well, I don't know if it's technically a motherboard, maybe it is. Anyway, your controller board from getting all these little pieces of filament in there. You can print, there are several covers that you can print that will prevent it, to still let air flow in, but prevent all these little kind of things from falling in there. I have not done that on this printer. That's a decent, relatively simple one of the upgrades if you want to print something. There's the screw in the back. This one's longer, so you do have to keep it in mind that when you go to put them back, the long one goes back here. So that one's that length. The front ones are. So there's the difference. All right, so this little cover, it won't come all the way off. It does have a wire that's going to this fan. So you can kind of just set it off to the side like that. And there's your little control board. So one thing we need to know, oh, that's interesting. All right, so let's see. There are multiple versions of these boards, and we're gonna need to know which version we have for our firmware step. And I'm trying to get down there to it. So let's see. It's kind of, I may have to turn the light off of it. No, you can see. No, you can see better with the light off. All right. So right in here, that version 4 2.2, I actually assumed this was a 2.7 board, but it's not. It's a 2.2, so it's a little bit older board. Again, this was the $100 printer, so this is probably some old stock that they're trying to get rid of. But we need to know what board version it is so that we can get the right firmware for it. Sometimes there's also a letter printed here on the SD card slot that will, or not printed, it's usually written, that one has a sticker, like a C, that will distinguish between different board types also. This one won't need that, being the 2.2 board. But it does have what we need for now. This little slot right here. Again, this ribbon cable goes to your LCD screen, your little control board screen. So don't undo it. You'll see lots of like hot glue. That's so that these things don't come loose during shipping or just, I guess, rough printing or rough handling. The only downside to that is that when you go to unplug some of these, you got to scrape off that glue. And we are not going to use, let's see if I can get the, yeah. So you see X, Y, and Z. Those are the little end stops. So those are the mechanical triggers that are telling the printer where the limits are. We're not going to use Z anymore because we're going to use the new sensor as measuring where the bed is. So we don't need the Z end stop. So we need to unplug the Z one. And it's coated all with this hot glue. I did not think about that, but we're going to have to get in there and kind of chip away at some of that glue so that we can get the sensor unplugged. We could possibly just unplug it the other end. I think that'll work easier. I think that'll work easier. So instead of unplugging this one in, I want to find the other end of this over. Running out of room. Over here. I'm just going to unplug it there. So I think that'll have the same effect of disconnecting it, where it doesn't do anything. I'm also, while I'm thinking about it, I don't want this to be a mechanical stop and prevent the carriage from lowering. So I'm going to loosen those two and just lower this down. I'm going to leave it there, I think, for now. Or you could take it off, but it needs to be lowered. So get that out of the way, and we'll just lower it out of the way so that it's definitely not going to get in the way of anything. Or, like I said, you could just remove it. Okay. All right, now we need to route our new wire. I'm trying to decide. I'm going to route it so that it doesn't get tangled with the other wires. And there is you can barely see, there's a slot cut in the bottom extruded aluminum frame where the other wires come in. There should be enough room right beside that slot to put our new wire in from there. So that's what my goal is. I may have to move things around to get this to work. So we'll see. Oh, I should mention that you should unplug your printer while you're doing this, because you definitely shouldn't have it on, but you should probably also unplug it. All right, there comes our wire. So the way they cut this slot is they just milled it into the piece of aluminum. So sometimes it has sharp edges, and so be careful that you don't cut your wires or strip the insulation off when you're pulling this through there. All right, so this will just plug in, and again, same kind of deal where it only has one direction it can plug, and that's it. So now I'm gonna be brave and go ahead and close this back up. There seems like there's always a chance that I have to undo that and go back in there, but we'll try and see that we get it right the first time. All right, so now we don't have a Z end stop any longer. We disconnected the cable from it. I might have to loosen those a little bit. We do have a sensor, but the printer doesn't know it has a sensor. Plugging it in doesn't automatically tell it that, hey, now you have a sensor that you can use. So that's where we need to go to the firmware. So let's see if I can get this. There we go. I think that started. And I've got a big bundle of wires back there that I'm not going to worry with those until we get everything working, and then I'll try and route the wires in a neater way. All right, so we can't print now though. So until we give it new firmware, it doesn't know what to do with this sensor, and it's just going to crash because there's no Z end stop plugged in. All right, so let's go and find us some firmware. So if you're on the web page here, then you could go and download the Marlin firmware, and it will take you to this page. So Marlin firmware. Can you see? Oh, you can't see the web address. So the web address is marlinfw.org, and then that'll get you to the main page, and then you navigate over to download. So download Marlin. Marlin is the open source firmware that's already on your printer for the most part. You might have a printer that has something called Clipper, or maybe there's something even different from those two. When you were doing the change for the nozzle to the hardened steel, oh yes. So that's a good point. When we put new firmware on, we're going to lose any tuning that we had before. So we're going to lose our PID tune. If we had changed E-steps, they're going to be gone. So one thing you might want to do is either write down the settings that you used. If you remember them, you can usually go into your printer's, like we could go over here. We can turn the printer on. It'll be fine. We just can't print. We just can't cause it to home, because it won't home here. So we could go over here and review our settings for E-steps and PID, all those things, so that we can transfer them over to the new firmware. Because once we put the new firmware on there, all of that's going to revert to whatever defaults are in the firmware code. But we could either retune them, which doesn't take too long, or we could just put them into the firmware when we go to upload. I'll show you where they go. So I'm going to just retune everything, because I'm probably going to put a different nozzle back into our printer. I really like the 0.6. I've just got to get one. Actually, my plan is, now that I have an extra 0.4, I'm just going to drill this one out to 0.6, and that'll be good. I believe I have a 0.6 millimeter drill bit over there, and we're just going to drill it out. And that way we'll have a hardened steel 0.6. I don't know if these things are just case hardened or if they're through hardened. But this is essentially free to me anyway, so we're going to do that. All right, so back to our firmware. You get there. You see some of these that are 1s and some that are 2s. So unless you have a very old printer, like 5 years, or in printer life, then 5 years is very old. 5 years or so, or at least old, then you're using the Marlin 2 version. The difference is the processor type on your board. Is it a 8-bit or a 16-bit processor, or a 32-bit? Actually, maybe it's 8 and 32. Maybe there's not a 16. All of the newer boards, even this slightly older but newer board that we're going to use in this printer, is a 32-bit board. So we're going to use version 2 of Marlin. And then we have to choose, do we want this current Marlin release or this LTS? I'm going to do the current Marlin release. Usually the current Marlin release doesn't have the latest, like there are quote-unquote nightly sources that nightly builds where they go and try to fix all the little bugs people have found. I usually don't worry with those. I usually just get the one that's current. So you download that. So I've already done that. You also want to download these configurations, unless you just want to start from scratch, which there's a lot of configurations. So I downloaded both of these files. This file, so I'll be running Marlin 2.1.2.4, and I downloaded this, which is just a set of starter files for all your different printers. And I'm sure that our little instruction manual over here, so our instruction manual probably directs us directly to the Creality store, where we can just download a pre-built thing. But I don't want a pre-built thing. I want to go and change that temperature. I also want to make for sure certain that the thermal runaway is enabled. And there's a couple of things that I just want to do personally. Plus, I want to show you how to get into the firmware. But there are pre-builds that you can just download and load it onto your printer. That's it. We're going to do a lot more than that. So if this is intimidating, or like you don't want to do all this stuff, then you can get a sensor and a pre-built firmware for it that you just load it on. You put it on your SD card, put the SD card in the printer, and you're done. We just don't want to do that. So I downloaded these two things. All right, so let us go and let's go back here. So guide for setting up VS Code. Let me make sure this still works. Yes, it does. All right, so this is another way you could go about changing your firmware. TH3D. I really do like their firmware. They have it's still Marlin, but it's not free. I think it's like $5 maybe. I can't remember. But they have a pretty step-by-step guide for installing VS Code. This is going to be our code editor. So all of this firmware is written in basically Arduino code. So you could hack your way through it without VS Code, but you have to compile it to put it on the printers. And that's kind of hard to do outside of, this is the easiest way to compile it. So they have a step-by-step guide on, like, click here, that, type this, next, you know, all that. It's very thorough, and I am assuming that you either already have VS Code or you're going to need something like this where it walks you through step by step. So I've already done that. I'm not going to take time to follow all these button pushes, but this is the best one I've ever seen for this purpose of walking you through how to get VS Code running. It's free. You don't have to pay for this or anything. And you might want to look at their firmware. I do like their firmware. It's just, I don't think it's free anymore. I think it's pretty cheap, like $5, but not free. So we're going free. All right. All right, so I've got VS Code, and it should be up and running. Here it is. I have already, let me take you to the desktop so you can see that. Maybe that one? There we go. All right, so I've already taken, and there are my two zip files I downloaded. I've already extracted them into their folders. So this folder, the one called Marlin, has the firmware in it. So if I open this folder, you will see a Marlin folder inside of here. And there aren't many files in this one, but there are these two files. So these files, there are a bunch of files that you could edit and change, but these are the two that contain the specific information for your printer that you're most likely to edit. Unless you really, really know what you're doing and you're trying to develop some very specific thing, these are the two you're working with, and you're really probably only working with this one. But this is another one that you might work with. So these that are in the Marlin folder currently are kind of just generic. That's why we downloaded this configuration. So if I open this folder, this is the other file. This is the, is it still open? This is this file right here. All right, and I've already extracted it. So I'm just going through the menus. All right, so back to the beginning. There's only one folder, so you open that one. Then there's only one folder, you open that one. And then examples. And there are many, many. So more than likely, your printer is in here. Unless you just have a really very unique printer. It's probably in here. So here's our Creality. And then there's a bunch of Crealities. There's our Ender 3. Then there's a bunch of control boards that might be on your Ender 3. So these Big Tree Tech, I like those, but those are kind of upgrade control boards. There's our 4.2.2. So there's what we need. And so inside there are these 4 files. We're going to take and put those 4 files in here. Actually, the boot screens, where did the boot screens go? I actually don't remember where the boot screen and status screen goes. We're just going to put them all right here, and so these boot screen and status screen, when you turn on your printer and it hasn't fully booted up, the little display will show, for the Creality, it shows kind of their Dragon logo and Ender 3 underneath it, I think. That's what this boot screen does. Status screen is when your printer's running. There's a little logo in the top left corner, and some like temperatures and things like that. That's what this is also. So I'm just going to Control C and Control V over here, and I'm going to replace the existing configuration H and advanced H. So that's that. Now these boot and status, they probably actually go somewhere else. Let's see if we can find where they go. That might be the one that we just used. Let's see if I can make this. It says it's in the Marlin folder, which I think is where we put it. So that's not the one that we need. Maybe that will. All right, we're just going to put them there and see if that works. It'll be fine because they're just pictures for the most part. All right, so we can close that. So all we did there is we took the pre-built Ender 3 for my version board 4.2.2. So you have to find what your board is, and we put the pre-built configuration file and configuration advanced file into the Marlin folder. That's all we did. So then we go to our VS Code, which hopefully you've set up. I'm actually going to close this folder. Actually, I'll just refresh it. Okay. So this configuration.h, if you've seen Arduino code, this looks familiar. This is what I need to change for all the changes I want to make. So unfortunately, I thought I had a 4.2.7 board, so I already went through and tracked down all the changes I want for that. So we'll have to find them again here because it might be slightly different for the 2.2 board. Oh, I'm in the configuration.h file also, so you can make sure you're in there. All right, so I'm just scrolling through. There are thousands of lines of code here, and I'll just kind of scroll through and talk through some of the stuff that as we see it. So serial ports, baud rates. You should not want to change any of those things. There's the message. So you could actually change this if you wanted to. You could change any text here and it'll show it on your little printer screen. Stepper drivers. So this is the A4 988 drivers for X, Y, and Z. That's based on being the 4.2.2 board. There's the extruder driver. I only have one extruder. That's fine. Normal filament diameter. There's a lot of stuff here that's commented out because I don't have these things, and most don't. But maybe you had a magnetic switching tool head, so your printer goes, grabs a tool head, prints with it for a while, and then docks that one and grabs another one. Here, how you can turn that on. Mine does not have that. Mixing extruder is maybe there's two types of filament going into a single extruder and they get melted together. Mine does not have that. Power supply control, thermal settings. So this is one of the things I wanted to change. So when we changed the hot end, I did mention that there are these little cartridge type thermistors that can read higher temperatures. This is what I would need to change if I actually changed the thermistor. I did not do that. I kept the glass bulb type that was on the printer, so I don't need to change this. But here are all the thermistors that you might change, and you pick one of them. Temp sensor 0, and I guess there's a temp sensor bed. So you pick the one that you use, and then it'll be calibrated to use that particular type of thermistor. All right, so now we're getting close to what I do want, though. Let's see. So heater 0 max temp. Now this actually has through heater 7, so you can actually have 8 different heaters. Mine does not have that. They're all set to 275, so this one actually did bump up from the 260 we were limited to, but I actually want this to be 300. I want to go all the way to 300 on this, and I'm going to change the other one also just in case it's labeled heater 1. There is the bed. Now this one says the bed at 125. We were limited to, I believe, 100 before. I'm not sure this little bed can ever get to 125, but we'll leave that. We do not have a chamber heater at all, so 60 is fine. Here is, you had asked about the PID numbers. Here's our PID coming up. So here are the default numbers that are going to be set into our printer, which I didn't look and see what our numbers were. I'm just going to rerun a PID tune when we get everything back up and running. So, but you could, if you had written them down, you could put your new PID numbers in here. They have 2 sets here if there are 2 extruders. Let's see, just scrolling through some of these other things. If you wanted, you could set PID tuning on the bed. So instead of just bang bang where it's on and off, you could have PID tuning for the bed also. If you want that, you uncomment this line right here. So now I would have PID tuning on the bed. Why not? We'll put that on and see how it goes. We'll definitely have to tune that because I don't know at all what the numbers are. We don't have a chamber, so we don't need that. The PID for a chamber. Here, you know, maybe you have tried to load filament and you want to make it extract the filament not manually, automatically, and it won't do it or it won't extrude. This number is your extruder won't run unless the hot end is reading at least this number, so 170. 170 is at the lowest of the low ends for being able to extrude PLA. So if you printed hotter temperatures, maybe hotter materials, then maybe you want to change this. I'm just going to leave it alone. Oh, here's thermal runaway protection. So this is the one where if a thermistor falls out, that's particularly what I'm worried about, or if it breaks somehow, then it will not read the right temperature, and your printer without thermal runaway protection would keep trying to heat the heater block, and something eventually is going to fail. Either the block itself will melt, or you know, something will more than likely brown out and shut the printer down. Hopefully that happens, but it can be dangerous. So this one is, all 4 are on. So I have thermal runaway for hot ends, bed, chamber, and the cooler, laser cooling. I don't have that, but I have all of these are turned on, so that's good. I'm not going to turn those off. Let's see what else we got in here. These are all different types of printers. None of this is stuff we need. In-stop settings. So we're getting close to where we're going to turn on the CR touch sensor. So these are all, you know, maybe you've changed out the in-stops and they're pull up versus pull down or whatever, but you can change all of that. I don't need to do any of those things. I can have a whole bunch of in-stops apparently. Let's see, there's our steps per millimeter, X, Y, Z, and our E steps. So if we had tuned our E steps and knew the right number, we could change this number right here. you hardly ever need to change X, Y, or Z unless you have changed something mechanically on the motion system of your printer. I never did tune E-step, so I'm just going to leave it at the default value for Ender 3. Here are feed rates. You know, if we were trying to do some high-speed printing, then maybe we want to have faster feed rate maximums. Right now, our firmware is going to limit us to these movement rates. So feed rates is how fast does a part move. So again, it's X, Y, Z, and the extruder. Same thing with max accelerations and jerk, which is the derivative of acceleration. All right, Z probe options. That's what we've done. We have added the CR Touch is a Z probe. All right, we're gonna say, first of all, force the use of the probe for the Z-axis homing. We're gonna do that because we have disconnected our mechanical switch, and so we want the Z probe to actually do the Z homing. Okay. We shouldn't have to change the pin type. All right, so the probe type, there are several of these in here. Manual, mounted fixed, or fixed mounted, nozzle as a probe, servo, BO touch. So ours is technically a CR touch, but it uses the same coding as a BO touch. All right, so I'm just enabling these by uncommenting out their slash marks. Maglev 4, all these different touch sensors. Okay. Still in the sensor types. Okay, this little diagram. So let's go back to our printer. Where's our print head? So our nozzle is somewhere over here, right there. You can't see it, but it's right over here. The sensor is over here. So we need to know the distance between these, and that's what this is. This is asking for. It's asking for, in relation to the nozzle, the N, where is your actual sensor? So sometimes the little manual will tell us these values. I don't know if it did or not. I'm going to look through them and see. All right, I don't see anywhere in the manual that it tells us the offset. So we have one of two options. One option is we can go over to the printer and measure that. Another option is we can search on Google, and I mean, since this is a standard mount, then somebody's already measured it. So I'm going to show you the measuring route just because that's a little bit more interesting, I suppose. So what we'll do to measure it is I'm going to, I'm going to attach a sheet of paper here. Let's get it over there. And I'm going to get a straight edge here. And I'm going to draw an X to find the center. So I'm going to draw from corner to corner of my bed to find the center of the bed. If I can find something to write with. Here's something. So let's see if I might have to move this little deal. Okay. There's one part of the X. This other one might be a little tricky because I got it. All right, so roughly there's the center of my bed. Now I'm going to put the nozzle directly on that X. I've got everything off right now so I can manually move things around. Got a little leftover piece of filament on here. Okay. We don't have to be, I mean, we want to be pretty accurate, but it doesn't have to be perfect. kind of need a light under there. Okay. I think that's more or less where the center is. Close, I think. And now I will mark where the probe is. Okay, and then we'll just move everything out of the way. And I need the distance in the X direction and the Y direction. I also need a Z, but we'll deal with the Z offset differently. So let's see, this is going to be in millimeters. So we're trying to get this, you know, parallel to our bed. So it looks like that must be 30, 40, 45 here. And then this one is harder to tell, but let's see. Let's actually draw us a... I could probably get some little bit more accurate way of doing this, but we're going to be all right. So that's... So not very far off this way at all. It's like, I don't know, 3 or 3.5. I don't think I can use fractions in here, but it looks like 3 or 3.5. So we can get rid of our paper. And we just put those numbers into our code here. So it says if it was on the left-hand side, it gets a negative sign, so negative 45. And if it was in front, it gets a negative sign, so negative. And I don't know if I can, it doesn't tell me if I can use decimals. None of these others examples have decimals. We'll go with negative 3. Let's just do negative 4 and carry on without decimals. All right. So the other thing I need to tell, so this one's kind of interesting, is so when you probe, you can set up a grid that will probe your bed in a variety of spots. So depending on your goal, do you have a flat bed that just might be tilted a little bit and you only need 3 points to define the plane? Or is your bed kind of wavy and you need a whole bunch of points to define the shape of the bed? No matter what, you have to decide that. And then you have to decide how accurate do I need to be. So, like, I probe one time and I get one reading. But what if I was off a little bit on that reading? So you can tell it to probe, you know, multiple times in the same spot and kind of get the average of those readings. You can tell it to probe fast and slow, and so all of that kind of stuff. I'm just going to say that my bed is more or less flat. It does have a dip in the middle. It's more or less flat, and it's not very large. So the larger the bed is, the more this comes into play. But I don't want to spend a whole bunch of time before every print probing the bed. So I want to leave multiple probing off. But you could turn it on. And you could turn on fast probe. There's a lot of like styles of probing you could turn on. Let's see. This is all homing type things. Here, if you've changed your bed size, this is the standard bed size for a Ender 3. These software end stops are not actual physical end stops, but it's kind of like a software border around your print bed that it won't let the nozzle go outside of. I don't have a runout sensor, but if you had added one, you could enable that. So here are the routines you can use for bed leveling. So this is the one where you just get 3 points. You assume your bed is flat and it's just going to be tilted some amount. So you just get 3 points you'd pick, and that's way faster. And if your bed is flat, it just might be tilted, then this is a good enough way to do it. This one does, you know, anywhere from like 9 points to 25 points or more on your bed in a grid pattern, and it takes that pattern and it averages it out to figure out what shape is your bed, except it doesn't do like undulations, it just does a tilted plane. So it's the same as the 3 point, but it takes more data. So that one's not bad, and that might be the one that we actually use for this printer, because the bed's not very big and it's mostly flat, and we just kind of need, if it's tilted a little bit, we need to deal with that. If your bed is really warped or really large, this bilinear one looks like the linear one, except that it actually plots a mesh of the surface. So it's not just a tilted plane in the software, it's kind of like a hills and valleys. And then it will cause the nozzle to trace those hills and valleys as it goes over the print surface. That one is good if you have a really warped bed or a large bed. This UBL is kind of trying to do the best of everything. This one is, I don't even have a bed sensor, but I want to have the effect of a bed sensor. You can turn on mesh bed leveling. So down here, you would uncomment that. And now there'll be a routine built in your control panel that you can go around and manually mesh the surface of your bed. You don't want to do it before every print, but it can store that mesh and then account for the shape of your bed before every print. We're going to just do the linear one. I think this bed is pretty flat, and we just need it to be, if it's tilted, we need to know that. So we'll do the linear. Let's see, what else do we need to... That might be, I wrote down everything I needed to change. Let me check and see if I've left off anything that I wanted to change. We did thermal runaway. We picked out our board number. We did max tint. We did our offset. We talked about PID and the E steps, but we didn't change them. We're going to do that on the printer. And we made sure thermal runaway was enabled. One other thing, so that's all that we want to change in configuration.h. It's telling me there's an error. Where might there be an error? Oh, it's a include. Huh. Usually that will resolve itself, so hopefully it will. We're going to save this one. And I don't know where there would be. It's way at the top up here. Oh, it's that little squiggle mark. Oh no, it's that. Oh, that's just the comment. Huh. That shouldn't, I don't know what that's telling me. That shouldn't be a problem. We'll find out. All right, so now let's go to the advanced.h. There's one thing I want to check in here. It has the same issue with the little squiggle, or with the / comment. And that is, I'm going to just do a search, so Control F, and I want to find baby. So baby stepping right here. This is, I like including this. What it does is, as you're printing, you can go in your control panel and step in tiny little baby steps. You can step the nozzle up or down. So if you're noticing the nozzle is too far away from the bed, you can drop it down. If it's too close to the bed, you can raise it up. So I like having baby stepping enabled. It looks like it already is enabled right here. So it when I print the skirt around an object, I can watch the skirt and make any little adjustments to the baby steps up or down live during the print to get a better first layer. So there are several different factors that you can, parameters that you can change here. I'm not going to change any of them. I just wanted to make sure it was on. And it does appear to be on. So we'll save this one, although I didn't change anything. Okay. Now, assuming that it will fix these configuration error type things that it didn't like, which I'm not sure why. It looks like it fixed the .h one, but the advanced one is still an issue. All right, so what I do now is I go over here to this auto build Marlin, which is part of the installation steps that I showed you for VS Code. And what it will do is it will build my firmware, assuming everything went right. So I don't remember which one. I'm going to try the 512K one. I don't actually know. I think the sticker that I was talking about, or the letter that might be written on the USB slot, will tell you which one of these. I'm going to build this one. And if everything goes right, what will happen is down here I'll get a little, oh, I didn't, you know, all right, didn't recognize some stuff. Okay, so let me click it again. Still didn't like it. Let me try the Xfer one. Didn't like that one. Let's try the 256K one. Didn't like that one. All right, so sometimes it just needs a restart. So let me make sure I've saved these. And then I'm going to shut down VS Code and restart it. Because what will happen, particularly if you don't use VS Code often, is that it downloads a bunch of updates as it's working, and then sometimes those updates need a restart to take effect. So we're going to see if that fixes us. All right, so we're back with these. Here's auto build. Sure. Oh, I need to open a folder. All right. Still didn't like that. Let's manually open our folder versus see, it's over here in the bottom. It's doing lots of little updates and everything, so we'll let it finish out those before we try again. But let's open our folder, our Marlin folder. Okay, I think it's finished updating. I never can remember if you have to open the folder Marlin is in, or the, looks like you have to open the earlier folder. The workspace doesn't contain. Well, you know, they could have also changed something the last time I've done this. There we go. All right. Oh, it's still updating the platform I/O. All right. I wonder if it's gotten everything open yet. So. All right, let me try to close it down, restart again. Get all these steps in the right order. If we're about out of time, it's actually not going to finish in time anyway, because the compiling takes about, I don't know, 15 minutes or so usually. But I would like it to start so that we can pick up next time with what we need to do after that. But let me get everything. I'd like for it to start though, but it might be that we have to finish on Monday. All right, everything is loaded. We still have that one error that it's that same thing. That same thing. Looks like those are all closed. That looks like it's okay. Well, it's still giving me this error. I'm going to have to go find. It's trying to open this file, which it's not finding, which is not related to our Marlin. It's related to this guy, which for some reason I don't know if I moved that or I may have to reinstall that, but it's not finding that file. So I'm going to have to go see why it's not finding that file. And then, yeah, we have three minutes, so definitely not going to be able to do that in 3 minutes. But we'll start on Monday, pick up where this left off, and actually get our firmware installed on our printer. In the meantime, we could just go download a pre-built, so we don't have to do any of this, firmware for our printer and start printing if we wanted to. The process for installing, once you get either the one that we're doing here or your pre-built, is you put that firmware. I usually put it on an empty SD card, although it will work on cards with other files, and put it in your printer, turn your printer on, and it should do the update automatically. But we'll have to do that next time. All right, so I'll figure out why my file is missing here, figure out this, and then Monday we will compile our firmware and we will get our printer up and running, and then we'll look at that enclosure, because that seems to be the next step on getting us to be able to reliably print our carbon fiber polycarbonate that we want to print. All right, I will see you on Monday.